Okay, so we got a CD. It's got a diameter of 130 millimeters. So draw myself a little picture. I can make it bigger. There's 130 millimeters. When playing audio, the angular speed varies to keep the linear speed constant. So the angular speed, which I see written with different letters, sometimes it's like that funny looking W. The angular speed is how many radians you travel depending on some time unit, or how much angle do you change over like 30 seconds. So you could say like, oh, it's gone 360 degrees in 30 seconds. That means it goes one revolution every 30 seconds. That'd be really slow, obviously. That's the basics of angular speed. How long does it take to complete some sort of angle? Linear speed, which is sometimes lowercase l, is found by taking the distance it travels and dividing it by time. And those are different, right? The angle changes at a different rate than the distance does. So let's say we go a full revolution around this circle. So this circle is 130, so it's 65 2 pi r. So that's 130 pi is the circumference of that circle, right? If it's 130 diameter, radius is 65, and our old friend 2 pi r tells us how long it takes to travel. And if it tells us we make one revolution every 2 seconds, that would be linear velocity. Okay, so they're both measuring, how fast the disk is spinning, but one's measuring it based on the angle, and one's measuring it based on the distance of that outer edge. That's not like, these are numbers that I've just made up about seconds. It's just to give us an idea of what angular and linear velocity is talking about. So for this problem, they tell us that the angular speed is 240 revolutions per minute. So let's write that out a little bit more. 240 revolutions for 1 minute. Right, and so that's the angular speed. Let me think here. The quick way of figuring out the linear speed is to convert this to radians per minute. Okay, so you can multiply by, we travel 2 pi radians. Sorry, yeah, 2 pi radians per minute. There's 2 pi in radians for 1 revolution. Okay, so one total spin around the disk, that's 2 pi in radians. Because remember, radians is talking about the unit circle. We have a radius of 1, and so using pi r squared, the total distance around this circle is 2 pi. So this is getting us towards that idea of the linear speed, that it's this total distance. When we convert it to radians, now we're starting to talk about the circumference of the circle instead of talking about the angular speed, how fast the angle is changing. So let's do that. Let's make that conversion. And look, you might be saying, like, why did you put 2 pi radians over 1 revolution? And why didn't you do 1 revolution over 2 pi radians? It's so that we can make our units cross-cancel here, because we want to be talking about the circumference of the circle. So if you cancel out the word revolution, now you have 240 times 2 pi radians for each 1 minute. And now we're ready to finish converting this. The linear speed is going to be the revolutions, the radians, I should say. Sorry, different word. Radians per minute times the radius. So up here, if I simplify that, 240 times 2 pi, that makes 480 pi radians. I'm just going to write rads for 1 min. Then we multiply that by the radius. Now the diameter is 130, so that means the radius is 65 millimeters. We'll just want to keep in mind our final answer is going to be in millimeters. So 480 times 3.1415 times 65. We've got 98,400 14.8 millimeters for 1 minute. But then they want the final answer in meters per second. So 98,014.8 millimeters per minute. Let's see if I can get rid of this. To make that conversion, we want to have meters in the top. So I'm going to multiply by it using a conversion factor. There's 1 meter in 1,000 millimeters. So if you do that fraction arithmetic out, it's just like multiplying straight across the top, straight across the bottom. So you're essentially dividing by 1,000 there. So it gives us 98.0148 meters, because these units cross cancel, per 1 minute. And then they wanted the time period to be in seconds. So to make that conversion, we're going to multiply by the 60 seconds in 1 minute. Oops, I got that reversed, because those units won't cross cancel. It's got to be 1 minute per 60 seconds. Now these cross cancel, and so that means if you multiply something by 1 over 60, it means you're essentially dividing, right? Divide by 60, so we got 1.63 when we round to the second decimal place. Oh, I must have already done this one, because looks like that's the answer I already had typed in. Yeah, I think that's everything. Okay, so yeah, now that it's talking about in a distance around the circle instead of having an angle, it's 1.63 meters for 1 second. Now we're talking about linear speed. If the numerator is radians or degrees, then you're talking about angular velocity. If the numerator is now, once you convert your units, if that is in some sort of measure of distance, then you're most likely talking about linear velocity.